Good morning, students. Here we discuss a new chapter that also belongs to this physical chemistry part, which is chemical kinetics. The word kinetics. I think you are familiar with kinetic energy due to motion. Or chemical kinetics is a branch of chemistry which deals with the rate of a reaction and also the different steps involved in the conversion of a reactant to product, or which is generally termed as the mechanism of the reaction. Chemical kinetics mainly deals with the rate of a chemical reaction and the different steps involved in the conversion of a reactant to product. You know, in lower class you have studied about this chemical reaction. A chemical reaction is the conversion of reactant into product. Or with increase in time, the concentration of reactant decreases while the concentration of product increases. That is, here that is symbol graph concentration against time. Here the reactant concentration decreases and the product concentration increases. That decrease in concentration of reactant or increase in concentration of product, or the disappearance of reactant as well as appearance of product, that is called a rate of a reaction. Decrease in concentration of reactant or increase in concentration of product in unit time is called a rate of a reaction. Rate of a reaction is defined as the decrease in concentration of reactant or increase in concentration of product in unit time. Okay, then that is simply we can represent it as rate equal to concentration divided by time. Since the concentration is expressed in moles per liter and time represented in second, then the unit of rate becomes unit of rate equal to mole liter inverse or moles per liter divided by second, or mole liter second. Moles per liter per second is the unit of rate, or rate is expressed in moles per liter per second, because rate equal to concentration by time, whether it is increase in concentration of reactant or decrease in concentration of reactant or increase in concentration of product. Anyway, concentration by term refers the rate of a reaction. Concentration is expressed in moles per liter, time in second. Therefore, unit of rate equal to moles per liter per second. Okay. Then there are two types of rate. The rate of a reaction is of two types, or there are two types of reaction rate. One is called average rate. Rate average. Rate of a reaction is of two types. One is average rate. Average rate means the rate of a reaction during a particular time interval. Rate of a reaction during a particular time interval. That is, suppose the initial concentration means at 0 minute the concentration is say x. After 5 minutes it is x minus 1, like that. Between 0 to 5 minutes, what is the rate of a reaction? That is called the average reaction. Once more, average reaction means the rate of a reaction during a definite time interval. During a definite time interval is called the average rate. Or for a general reaction, R gives P, the average rate can be expressed as, here if we represent the form of a square bracket, if R reactant is represented within a square bracket, it is called molar concentration or molar concentration of A. Here you can see that is time or average rate of a reaction minus delta R divided by delta T, where delta R is the difference. Already explain you by taking one example, that is the in 0 minute, that is called initial concentration. Right? When time equal to 0, the concentration is x. When time equal to 5 minutes, that 5 minus 0 will give the delta T, and x minus 1 minus x will give the delta R. That is equal to delta P divided by delta T. Here you can see there is a positive side. Here there is a negative sign which shows that the concentration of reactant decreases with the time, and here you can see there is a positive sign which shows that the concentration of product increases with the time. That is why rate of a reaction equal to decrease in concentration of reactant or increase in concentration of product is called a rate of a reaction. Plus sign indicates the concentration increases, and here there is a negative sign which shows that concentration of reactant decreases. Okay. Then second type of reaction rate, that is called instantaneous rate. Second type is called instantaneous rate. Instantaneous rate. Instantaneous rate means rate of a reaction at a particular instant, a particular moment, the rate of a reaction, that is called a instantaneous reaction. This instantaneous reaction, instantaneous rate is preferred over average rate. The rate is mainly expressed in terms of this instantaneous rate. For the above reaction, that is R gives P, the instantaneous rate equal to, instead of delta, if here we take D minus dR, concentration of R divided by dt, delta T, here it is dt, equal to minus dP divided by dt. That is, concentration of reactant decreases, concentration of product increases. There are two types of reaction. One is average rate. Once more, chemical kinetics is a branch of chemistry which deals with the speed or rate of a chemical reaction and the whole steps involved in the conversion of reactant to product. A chemical reaction is the conversion of reactant into product. The decrease in concentration of reactant or increase in concentration of product in unit time is called rate of a reaction. Rate of a reaction, decrease in concentration or increase in concentration of product. There are two types of rate. One is called average rate and other is called the instantaneous rate. The average rate does not have very much significance nowadays. At present, this instantaneous rate is preferred over average rate. And for a general reaction, A plus B gives C plus D. It is clear that 1 mole of A react with 1 mole of B gives 1 mole of C and 1 mole of D. The average rate average equal to minus delta A by delta T, that is equal to minus delta B by delta T. Since both A and B are reactant, we put a negative sign and minus delta C divided by delta T equal to plus delta D divided by delta T. Here you can see that both C and D are product, their concentration increases with the time. In this equation, we take 1 mole of A, 1 mole of B, 1 mole of C and 1 mole of D. For the same case, the instantaneous rate or instantaneous equal to minus dA divided by dt equal to minus dB divided by dt equal to plus dC divided by dt equal to dD divided by dt. That is, by writing this rate, we can say that is minus dA by dt equal to dC by dt, or minus dA by dt equal to dd by dt. Similarly, this is equal to this one equal to this one. If we know the rate of, it is called a rate of disappearance. The concentration of reactant decreases, it is called rate of disappearance equal to rate of appearance. And this is the expression for instantaneous rate. And for a general equation, A moles of A plus B moles of B gives C moles of C and D moles of D. For a general reaction, A moles of A plus B moles of B give C moles of C and D moles of D. The average rate and instantaneous rate. Here small a, small b, small c and small d are the coefficient of reactant and product. In this case, the average rate is expressed as minus 1 by A delta A by delta T equal to minus 1 by B delta B divided by delta T equal to plus or 1 by C delta C by delta T equal to 1 by D delta D by delta T. Or the instantaneous rate or instantaneous equal to minus 1 by A dA by dt equal to minus 1 by B dB by dt equal to 1 by C dC by dt equal to 1 by D dd divided by dt, where small a, small b, small c and small d are the coefficient of reactants and products in the above equation. Okay, by doing this we can by knowing the relation, we can do some numerical type questions based on the rate or especially average rate. That is, calculate the rate of disappearance of hydrogen if rate of formation of ammonia is 1.3 into 10 raised to minus 3 in the equation N2 plus 3H2 gives 2NH3. N2 plus 3H2 gives 2NH3. Okay? Here you have to calculate the rate of disappearance of hydrogen. Since hydrogen is in the reactant side, its concentration decreases with the time. And ammonia is on the side of product, therefore concentration increases. And the equation is already given. For that you apply this instantaneous rate. That is, here coefficient is 1. Therefore, instantaneous rate equal to minus dN2 divided by dt equal to, here coefficient is 3, 1 by 3 dH2 by dt equal to, here on the product side, 1 by 2 dNH3 divided by dt. That is, applying instantaneous rate, it is equal to minus dN2 by dt equal to minus 1 by 3 dH2 by dt equal to 1 by 2 dNH3 by dt. Here the relation is in between that of hydrogen and ammonia. Therefore, we consider only this relation. Otherwise, if they are given the relation between nitrogen and ammonia, and at that time you take the relation minus dN2 by dt equal to minus half into or 1 by 2 into dNH3 by dt. Here we have to calculate minus dH2 by dt, isn't it? Rate of disappearance of minus, or from this relation we just equate minus 1 by 3 dH2 by dt equal to 1 by 2 dNH3 divided by dt. Here we have to find out minus dH2 divided by dt equal to, that is minus dH2 by dt is the rate of disappearance of hydrogen equal to 3 by 2 dNH3 divided by dt. dNH3 divided by dt is the rate of formation of ammonia. That is equal to rate of formation of ammonia, which is given. That is 3 by 2 into 1.3 into 10 raised to minus 3. Approximate 1.985 or 2 into 10 raised to minus 3. And another question, in order to understand how to write this instantaneous rate, take another question, that is ammonia oxidation of ammonia in presence of air. You just write the expression for instantaneous rate. That is, write the expression for instantaneous rate in the equation 4NH3 plus 5O2 gives 4NO plus 6H2O. Write the expression for instantaneous rate. Here R instantaneous equal to minus it is on reactant side, minus 1 by 4 dNH3 divided by dt equal to minus 1 by 5 dO2 divided by dt equal to 1 by 4 dNO divided by dt equal to 1 by 6 dH2O divided by dt. That is minus 1 by 4 dNH3 by dt equal to minus 1 by 5 dO2 by dt equal to 1 by 4. Here, since ammonia and oxygen belongs to the reactant side, you can see there is a negative sign, and nitric oxide, one of the oxide of nitrogen, don't read it as no, nitric oxide, and here water 1 by 4 dNO by dt equal to 1 by 6 dH2O by dt. That is the expression for. And if the disappearance or formation are given, then you can relate the things given in that question. Okay, that's about the instantaneous, how to write the expression for instantaneous rate. And consider a reaction A plus B gives product. The rate of a reaction is proportional to molar concentration of A raised to X into molar concentration of B raised to Y, or rate equal to K into molar concentration of A raised to X into molar concentration of B raised to Y, where K is called the rate constant of a reaction. X and Y are the terms which depends upon reactant A and B. Here X and Y are expressed as the power of the reactant concentration, and this expression of rate is generally called a rate law or rate equation. Here it can be seen that the concentration of A depends upon X and concentration of B depends upon Y, and X and Y are the power of concentration of reactant. The sum of the powers of reactant concentration expressed in the rate equation is called the order of the reaction. Sum of the power of reactant concentration expressed in the rate equation is called the order. the actual number of atoms or molecule present in a reaction. Here the coefficient of A is 1 and B is also equal to 1. The actual number of moles of A or actual number of reactant take part in a chemical reaction is called its molecularity. Okay, and it just distinguish the order and the molecularity. Difference between order and molecularity. Order and molecularity. That is, order of a reaction is the sum of the SAOM. Order of a reaction is the sum of the powers. Sum of the powers of reactant concentration. Sum of the powers of reactant concentration or concentration of reactants expressed in the rate equation. That is, rate equation is the representation of a chemical reaction in terms of reactant as well as the coefficient of reactant. That sum of the power of reactant concentration expressed in the rate equation is termed as order of the reaction. Okay, sum of the powers of reactant concentration expressed in the rate equation is called the order of a reaction. Then what about molecularity? It is the actual number, exact number, actual number of atoms or ions take part in the reaction which simultaneously collide each other to bring a chemical reaction. Molecularity is the actual number of atoms or ions which simultaneously collide with each other. Those collision which leads to a chemical reaction is called a effective collision, which simultaneously collide with each other to bring a chemical reaction is called a molecularity. Then second one, order is, it is an experimental quantity. It is an experimental quantity. Order is calculated through experiment, while molecularity is a theoretical concept. Molecularity is a theoretical concept. Then order can have 0, fractional or integral value. Order can have 0, fractional or integral value, while molecularity can always have integral value. Molecularity always have integral values. In some cases, not in all cases, in certain cases, order tells us about the mechanism of the reaction. In certain cases, order tells us about the mechanism of the reaction. That is, molecularity, it does not tell anything about It does not tell anything about the mechanism of the reaction. That is the main difference between order and molecularity. Order, molecularity. Sum of the powers of reactant concentration expressed in the rate equation is called order. It is the actual number of atoms or ions which simultaneously collide to bring a chemical reaction is called molecularity. Order is an experimental quantity. It is determined through experiment and it can have zero fractional or integral value. Molecularity is a theoretical concept and it can have only integral values. In certain cases, order tells us about the mechanism of the reaction, while molecularity does not tell anything about the mechanism of the reaction. This is an important question for your board exam. That is, differentiate order and molecularity. That is once more. Chemical kinetics mainly deals with the rate of a reaction. The mechanism through which a reaction is carried out. Mechanism means the whole step. By convention, we simply represent a chemical reaction by using a single equation, but actually that reaction is carried out through a series of steps. Such a reaction is generally termed as complex reaction, and in a complex reaction, the slowest step is always the rate determining step. That is the slowest step. And the rate of a reaction is the decrease in concentration of reactant or increase in concentration of product in unit time. And rate is expressed in two ways. One is called average rate and other is called instantaneous rate. Rate of a reaction at a instant of particular instant is called instantaneous rate, and during a time interval is called average rate. This instantaneous rate is always preferred over the average rate. And in the rate equation, if the concentration of reactants are expressed as the powers, that sum of the powers of the concentration of reactants expressed in the rate equation is called the order of the reaction. Order may or may not be equal to molecularity. Not in all cases order and molecularity are exactly one and the same. It may differ. Okay. That's about this chemical kinetics for this session. I think all of you understand, and in the coming session we find out the unit of rate constant or unit of different order. You know how to arrive the unit of order of different types of reactions, and there are some expression or derivation for the rate constant of certain reactions such as zero order reaction, first order reaction, etc. Okay, thank you.